Okay. Okay, so here are the steps if you want to take a picture and write it down. These are the steps to solving the log and exponential equation. No matter what, we always take these same steps. Every problem is going to come out algebraically a little bit different, but we know algebra. We know how to solve for x. So luckily, we're just adding on one more step here. So first, what we're going to do when we're solving a log or an exponential equation is we're going to isolate the exponential, get it all by itself, or isolate the log. So when I say isolate the exponential, what I mean by that is isolate the base, the exponential base completely. Get it all by itself. Or get the log all by itself. Now, if we have multiple logs, we might have to use properties of logarithms to put those logs together. To combine it so that we only have one log. That's our goal. So then after you've done that, the second thing you're going to do is now that you've got the exponential or logarithm alone, you're going to undo the exponential or undo the logarithm by applying the appropriate inverse. So what undoes base 2? Log to the base 2. What undoes log to the base 2? Base 2. So we'll undo the exponential or logarithm. And then after that, once you've undone the log or once you've undone the exponential, you can simply solve for the variable, solve for x, using just simple algebra. So you can't make algebraic mistakes, which is what tends to happen. And then fourth, the nice thing about these is we can always check our answers. And we're going to check them for extraneous solutions. Because we're going to take and manipulate these equations so much that it can introduce extraneous solutions. Now remember what an extraneous solution means. It means, yeah, you got a solution, but it's a solution of the new equation you've made by switching it around and moving it around. And even though you've done it correctly, it's this new solution that was introduced, and it's an answer of the new equation, not the original. So that's why we just check all our answers anyways. So here we go. First example. Like really, all we have to do is just get into some examples. So I would go off to the side, and I would take some notes during this time. So write down number 3 real quick off on your paper. You're going to need plenty of room. Okay, so our first step is to isolate the exponential. So that means get it all by itself. Now here, this one's actually, we're starting out with kind of a tricky one that tricks people, because this is really this. -1, the negative is not connected to the 11. This is really -1 times 11 raised to the 7n, which equals -1. So the first thing you've got to do is get the exponential base all by itself. So do you see how there's a -1 multiplied to it? We need to fix that first step. So we're going to divide both sides by -1. So we have 11 raised to the 7n is equal to +1. So we've got the exponential base all by itself. So now our next step is to undo the exponential. Get base 11 to go away so that we can have 7n down here. Because we can't get rid of 11, base 11, by dividing by 11, because it's base 11. So what undoes base 11? Log the base 11. So we're going to log base 11, and you have to do that evenly to both sides of the equation. So now over on this side, log the base 11 and base 11 cancel out. So 7n now drops down out of the exponent, which is nice because we're trying to solve for n. And over here, what we really have is log to the base 11 of 1. Now, what's our last step to get n alone? Divide by 7, divide by 7. So we've reached our goal, n is alone. So this is going to be one of our answers I want to see. So we have n is equal to log to the base 11 of 1 all over 7. Now you're going to have to go and type it into your calculator. So guys, you're going to have to really think about it. Do we know how to type that into our calculator? Yeah, but we have to use the what formula? Change of base formula. So I want to see you write it out. This is really n is equal to this, using the change of base formula, becomes log of 1, log of the big thing, divided by log of the mini thing. So that's really what we're looking at here, is this. Because I had to use the change of base formula to rewrite that. So now we have it at a point where we can type it into our calculator. So I want you to do that. Type it in, log of 1 divided by log of 11, hit enter, and divide it by 7. Let's make sure we all get at the right one. Type it in. It should should be 0. I show you type in log of 1 divided by log of 11 divided by 7. Now you have to make sure to close your parentheses around all of this. That's usually what ends up happening. So are you all typing it? Because today you can't not type it in. Like, you have to practice. Did you get 0? Okay. So n is equal to 0. If you didn't get that, let me come help you real quick. Look at everybody, look how we should check it. We're going to go back up and we're going to plug 0 back into our original problem. So we're going to go like this. Negative 11 raised to the 7 times 0. So you'll type into your calculator that, which what do you get? Negative 1. Isn't that what we should have got? So we have that equals negative 1. So we get negative 1 equals negative 1, which is a true statement, so we've checked our answer. Okay, let's do number 4. So your first step is to isolate the base. This is an exponential equation. We need to get the base all by itself. So our first step is to add 8 to both sides, right? Because getting the base by itself means nothing can be multiplied to the base or nothing can be added to the base or subtracted, obviously. Okay, so we have here 5 raised to the 3b equals 20. Now, can I divide by 5? No, because it's a base 5. So the only way to undo base 5 is to apply the logarithm that will undo the base 5. So log of the base 5 of both sides of the equation. So log of the base 5 and base 5 cancel out. That's what inverses do. So we have our 3b that drops down out of the exponent now, which is nice because we're trying to solve for b. We can't solve for b if it's stuck in an exponent. And then over here we have this, log to the base 5 of 20. Questions? Last step to get b alone would be divide both sides by 3. And now we're dealing with the same type of thing. So we have b is equal to log of the base 5 of 20 divided by 3. Now notice we don't know how to type this into our calculator without using change of base formula. So we would rewrite this as b is equal to log of 20. Using the change of base formula divided by log of 5. For that top part, I rewrote it divided by 3. So we get b is equal to, type it in. And we're rounding 4 decimal places, so 0.2605. Now here's the thing, I just want to make sure that you guys know how to type it in your calculator appropriately. We're going to want to use the entire decimal, not just part of the decimal. So I want to show you. So everybody learn this, because I'm going to have you checking your answers. Okay, so I'm going to show you. Everybody watch. So I typed in log of 20 divided by log of 5 divided by 3. Now watch to check it. So I don't want to have to retype the entire decimal. You've got to use the full decimal if we're going to check it. So we're putting it back into the original equation. So we have 5 raised to the parentheses. We have 3b in the exponent. So 3 times our answer. So watch how I can just type in without typing in the full decimal. I can get the last thing that was typed in as an answer back in here. So I hit second and then go to down here, this negative says answer above. That will put in the last answer that you hit enter of. I don't have to read in the decimal, it does it for me. Now I have to close my parentheses because notice in the equation it was 3 times b. Then minus 8 is not in the exponent. So I close my parentheses and I'm going to go minus 8. I'm going to hit enter. If it doesn't come out 12, my answer's wrong or I checked it wrong. 12. So we know we've got it right. You can hand in your test knowing I got 100%. Does that make sense, everybody? Okay, cool. So I know even though that decimal, right here, so our answer is that decimal. We were just checking it. But we know we got it right, because isn't that the value for b? Think about what an equation it is. You're saying, what value of b makes this a true statement? So does everybody see how we just checked it? Okay, awesome. Let's do another one. All right, number 6. Now notice, this is dealing with e now. E is just an exponential function. Just remember that E is just like any other base. Just like we had a base 5, E is just a number. Remember, it's approximately 2.7. Can anyone tell me what undoes E? ln. Now here's what I see students do. They get hasty and they just ln. Like, no, we have to isolate the exponential first. So our first step would be to add 2 to both sides. So we have e raised to the k plus 3 equals 78. And now because the base is isolated, we can now undo it. So how do you undo e? You just said ln. So we're going to ln both sides of the equation, because you have to do it evenly. So ln and e undo each other. That's what inverses do. So we have k plus 3 equals the ln of 78. Our last step to get k alone would be subtract 3 from both sides of the equation. So k is equal to ln of 78 plus 3, minus 3, sorry. That's a 7, not a 2. So you would type in, there's an ln button on your calculator, ln of 78 minus 3. So let's all practice this. ln of 78, close your parentheses, that's important, minus 3. So our answer is 1.35767. We're rounding 4 decimal places after the 1. So we got k is equal to 1.3567. Now that's our answer, but when we check it, we're going to want to use the full decimal, not the rounded answer like we just put. So we're typing in right here that full decimal. So watch how I type it in. You do second e, raised to it was the decimal plus 3. So I do second answer, and then plus 3 was in the exponent. So I'm going to leave it up there. Close my parentheses. So that I now know the computer knows that nothing else is in the parentheses. And then it was minus 2 after that. If we hit enter, we better get 76. Otherwise, we got it wrong or we typed it in wrong. So 76 is truly that really made it a true statement. So that was really our answer. Even though that decimal seemed weird, it was right. Okay, 56. So it says solve for x. So solve for the variable. So the first thing you do is isolate the base. So look, it's isolated. Nothing is multiplied to the base. Nothing is added or subtracted to the base. So now we're going to undo the base. What undoes e? ln. So we're going to ln both sides of the equation. So ln and e undo each other. So x over 2 drops down out of the exponent, which is what our goal was, to get x out of the exponent so we could solve. And then we have x over 2 equals ln of 25. Can anyone tell me what we do last step to get x alone? Good. What undoes division? You said multiplication. So we're going to multiply both sides by 2. So then 2 divides out. So x is equal to 2 ln of 25. You'll just type it into your calculator. So x is equal to 6 point, and this one, notice you'll have to read your instructions. This one's rounding 2 decimal places. 6.44. But to check it, you would type in the full decimal. Everybody good? Pretty simple. I mean, for the most part. Okay, awesome. I'm going to give you now a chance to start practicing checking your answers with me, but also be checking them yourself. Ready, set, go. Taking notes during this because there will be a problem like this on the exam. And there's not very many practice. In fact, this is pretty much the only one on here. So we have 27 raised to the negative 2k minus 3 equals 81 raised to the negative k. Now, what I want you to notice is different about this problem versus the problems we've done so far. Like, look at problems 3 through 10. All of those only had one base, correct? You see how this one has base 27 and base 81. So here's the thing. We can't undo log to the base. Here's the thing. We can't undo. Well, let's see. I wonder if we could. Anyways, there's multiple ways we could solve this. But here's the easiest way. Since they're both different bases, we could get these in the same base. So focusing on 27 and base 81, how could we get those in the same base? So a lot of people they see a 9, and that's where I started to originally think, but then 9 didn't work because 9 raised to the what power equals 27? Not 3, because that's 9 to the third, right? So that one didn't work. 9 squared is 81, but we can't get it in the same base with 9. But 3, base 3, we can get base 3, then both in terms of base 3. 3 to the what power equals 27? Third. 3 to the third power. And then 3 to the what power equals 81? 4? 4. So do you see how we can literally take 27 and rewrite it as 3 to the third power? And we can retake 81 and rewrite it as 3 to the 4th. So now they're both in terms of the same base. So this is what we really have. Instead of 27, we have 3 to the 3rd power. So we have 3 to the 3rd, and then raised to the negative 2k minus 3. Equals 81, we're going to rewrite as 3 to the 4th power. So we have 3 to the 4th power equals, raised to the negative k. So let's simplify this a little bit, because raise a power to a power and you multiply the powers. So we have 3 times all that stuff. So we have base 3 raised to the 3 times negative 2k is negative 6k. 3 times negative 3 is positive 9. Negative 9. Good catch. Negative 9. So we have that is equal to, so guys, what we've done is just rewritten this in a different form, base 3. So now over here, we have raise a power to a power and you multiply. So we have base 3 raised to the negative 4k. So now because they're the same base, we can undo that base. So what undoes base 3? So let's log base 3 both sides of the equation. So on this side of the equation, log the base 3 and base 3 cancel out. So negative 6k minus 9 drops down. Now on this side, notice, also the same thing happens. Log the base 3 and base 3 cancel out. So we're left with negative 4k. And now we can just solve. So do you see we're not even dealing with an exponential now that we got them in the same base? So then we can undo the base. So now we can just solve for k. So somebody tell me, what do I do from here? Just a linear equation. How do I solve this? Good. I like that. Add 6k to both sides. Negative 9 equals, now I'm combining my k's, right? So how many k's? Let's see, 2 k's? Solve for k, last step. Divide both sides by 2. So k is equal to negative 9 halves. All right, so same type of deal here. There's so many ways we could solve this one, because really we only have one base. So you guys go for it. Solve this one. So we could do this 2 different ways. I'll show you the first way. We could undo base 625 by log base 625 in both sides. So then over here, that cancels out with that. I'm not going to cross it out because I need to see the problem in a minute to do it the other way. So we would have 3x equals log to the base 625 of 25. So then you would divide by 3. Yeah. Remember, we have to use change your base formula. Yeah. So we have log of 25 divided by log of 625, right? Change your base formula divided by 3. So x is equal to, you get 0.166, which is 1/6. That's one way of doing it. Or you could have done it like this in this particular problem. Because base 625 can be written as base 20, I think it can be written as base 25. Oh, it's 25 squared. Okay, so we can rewrite this as 25 squared raised to the 3x equals 25 to the first power, right? So then over here, we really have 25 to the 6x equals 25 to the first. Now we can undo base 25 by log base 25 in both sides. So now that undoes that. So we have 6x equals, that undoes that, 1. So x equals 1/6. 2 ways of getting there. Okay, cool. So now what we're going to do is remember how to write these as a single logarithm. Go to 18. ln of 16 minus ln of 8. When you divide, then you subtract. So what we're doing, guys, is we're taking, since they're both ln's, we're making it 1 ln. Because we're going to have to do this in a minute when we're solving log and ln equations. So wouldn't we say this is ln of 16 divided by 8? Which is ln of 2. And we're done. Everybody understand? This is a review from last time, right? Okay, and over here, can anyone remind me what I should do here? First step. No one remembers what we do. Yes. I love it. We take this up into our exponent, and so does b, doesn't it? Anything multiplied in front. So rewrite it. We have ln of a to the third minus ln of 2 to the b. When you divide, then you subtract. So when you subtract, then you divide. So we can rewrite this, since they're both ln's, as one ln. So we have ln of a to the third, subtract, so we divide, divided by 2 to the b. So we've rewritten that as one ln. That's what we learned last time. So what I want you to do is speed through 18 through 26, go. Okay, here we go. So we're going to solve number 12. Now remember our steps to solving log or exponentials. Get one log on each side of the equation, or get one log so there's only one log on one side of the equation. You cannot undo log. Okay, everybody listen to what you cannot do. You cannot undo log if you have them split apart, because you can't do this. You can't go, oh, base 4, base 4, base 4. Here's why. You see the addition sign. You can't do that across addition. Does that make sense, everybody? That's like the similar idea of breaking the forbidden rule. So what we've got to do first is we've got to focus on each side of the equation and get only one logarithm. Well, nice. This is log to the base 4, log to the base 4. So can we write it as 1 log to the base 4? So let's do that. Log to the base 4 of, when you add, you multiply. So it would be x minus 10 times 9. So we've rewritten it as 1 logarithm. Equals log to the base 4 of 24. Now, because you have 1 logarithm on each side of the equation, or even if you only have 1 logarithm on one side, because there's 1 logarithm, you can undo log to the base 4. So what undoes log to the base 4? Base 4. So you got to do it equally to both sides of the equation. Now, in this particular problem, base 4 and log to the base 4 cancel out. So we're left with x minus 10 in parentheses times 9 equals, and over here, also it happens to cancel out. Log to the base 4 and base 4 equals 24. And now we can solve for x. So we can do this 2 different ways. I'm going to distribute 9 through. So 9x minus 90 equals 24. Now solve for x. It's just algebra from here. Everybody good? Okay. So we would add 90 to both sides, right? So we have 9x equals, perfect. I'm just going to borrow this. Divided by 9. Divide by 9. So let's give our answers in the simplified fraction and then also the decimal. So I typed in 114 divided by 9. I hit math, enter, enter, and I get 38 over 3. But I also get, it says round to the nearest 100. Round your answer to the nearest. Okay, anyways, let's do decimal too. Let's do 2 decimal places. So that would be 12.67. This would be how I want your answer. Okay, let's do another one. So number 15, we have log to the base 5 of x squared minus 10 minus log to the base 5 of 3 equals log to the base 5 of 2. Because we have 2 logarithms split apart by subtraction, we can't undo it. So let's put them together using properties of logarithms. Log to the base 5 of, when you subtract, you divide. So that would be x squared minus 10 on top, divided by 3. Does everybody understand me? Which equals log to the base 5 of 2. So now we would undo log to the base 5. How do you undo log to the base 5? Base 5, both sides of the equation. Base 5 and log to the base 5 cancel out. So we have x squared minus 10 over 3 equals, oh, over here it canceled out too, equals 2. Now solve for x. So it's just algebra to solve for x. So what would you do? Good, multiply both sides by 3. So over here, guys, those divide out. Don't distribute it through when they divide out. So we have x squared minus 10 equals 6. Now, because this is just x squared, there's no x. If there was x, we'd have to solve by factoring, getting it set equal to 0. But it's just x squared, so what would we do next? Add 10 to both sides. So we have x squared equals 16. Next step, for both sides of the equation, x is equal to? Oh my heck, you guys are awesome. Look at you not forgetting plus or minus. I'm very impressed. So then those would be our answers. We would need to check them. So we would plug in both plus and minus 4, and you watch it will work. So watch. If we plug it back into the original, we have log to the base 5 of, I mean, we just don't have time with it being a short data check, this one. Can I just move on? Sorry, we just really don't have time. Okay, let's do this one, number 27. So flip over to the back. Here we go, solve the ln. So the first thing you do is isolate the log. So what should I do first? Divide by 4. Divide by 4, right? Isolate the log. So then we have ln of x equals negative 1/2, correct? How do you undo ln? E, so we e both sides of the equation. ln and e undo each other. So x is equal to e raised to the negative 1/2. So then you would type that into your calculator and you get 0.61. This would be what I want to see. 2 decimal places. Anybody confused? Okay, let's do another one. 28. So what do you suggest doing first? We have to get the ln all by itself. So what should we do? Okay, divide both sides by 2. So we have ln of 3x minus 4, that's all trapped inside the ln, equals 7/2. Now what would we do? Undo ln. So what would we do to undo ln? E, both sides of the equation. So that's base e, right? So ln and e undo each other. So we have 3x minus 4 equals e raised to the 7/2. Next step would be to add 4 to both sides of the equation. 3x equals e raised to the 7/2 plus 4. Next step, divide both entire sides by 3, so that's x. Now we would type it into our calculator. I want you all to type this in, because this is what's tricky. People type it, you have to type it in like this. You have to go e raised to the parenthesis, 7 divided by 2, close your parenthesis. Then hit plus 4. Do not hit divided by 3 or your calculator will give you the wrong answer. You have to hit plus 4 and then hit enter. Here's why. Isn't all of it divided by 3? If you just hit divided by 3, it's going to do plus 4/3. E is also divided by 3. So you have to hit enter after you type that part in and then divide it by 3. So you should get the decimal 12.37. And then you could check it by plugging it back in up here into the original problem. You don't have to type in the full decimal though. So let's do 39. We have an ln of 3x plus ln of 2x equals 3. I'm going to ask you a question. Think before you answer for a second. Can I undo ln like this? E? No, why not? You're right. Yeah, you can only do it if there's one ln. There's a plus sign, so we can't do that. But can I combine those ln's? Properties of log. So wouldn't it be 3x times 2x? So this is really this. So we really have ln of 6x squared equals 3. And now we can undo ln by e-ing both sides, base e-ing. So ln and e undo each other. So we have 6x squared equals e to the 3rd power. Now solve for x. So our first step is divide by 6, right? Divide by 6. So we have x squared equals e to the 3rd divided by 6, and then won't we square root both sides? So x is equal to plus and minus the square root of e to the 3rd divided by 6. And that is the decimal. Which problem was this? Thanks, 39. 1.83. Now here's the thing. When we check the positive answer, it works. But when in this problem, when we check the negative answer, your calculator says error. So you would throw the negative answer out in this problem. But that's not true for all of them. You got to check them. So in this one, we would only do the positive. So we would cross out the negative. That's an extraneous solution. So you would type in positive 1.83, and then you would see that it works. And then you type in negative 1.83, and it will say error, your calculator. And so that's when you say, okay, I'm going to throw out the negative. Okay, 41. So we would divide both sides by 7 first, isolate the ln. So we have ln of 2x plus 5 equals 8 over 7. Undo ln by e-ing both sides. So we have 2x plus 5 equals e to the 8/7. Then when we just use algebra, solve for x. Subtract 5 divided by 2. Subtract 5, subtract 5. So we have 2x equals e to the 8/7 minus 5. Divide both sides by 2. So there's our answer. So you have to type in e raised to the 8 divided by 7, close your parentheses, hit enter, minus 5, hit enter, divided by 2. Negative 0.93. And that one works if you check it by plugging it back into the original. Okay, finish the worksheet. That's enough examples. The reason I rushed through is so I can give you the last 10 minutes to start some of those and practice and get help and whatnot. So do a couple out of each section.